and a number of different lobes, not unlike the cerebrum. Though, unlike the cerebrum, if you were to flatten out the cerebellar grey matter at the cortex, you'll see that this is one continuous sheet that extends from the left to the right hemisphere, or vice versa, depending on your perspective. The cerebellum can be divided in a number of different ways. Firstly, it is divided into a left hemisphere and a right hemisphere by a midline structure known as the vermis. The vermis consists of a superior part, which we can see on the model here, and an inferior part, which is approximately here. The well-marked horizontal fissure, which we can see here and here, divides the cerebellum into a superior half and an inferior half. Although this information is important from an anatomical standpoint, it is important to remember that these divisions have no functional significance. The much shallower primary fissure, which we can see here on the left and here on the right, divides the cerebellum into an anterior lobe and a much larger posterior lobe. This division is thought to have a functional significance, something of which I will discuss later on in this video. When we rotate the model to look at the inferior surface of the cerebellum, we can see an additional structure known as the tonsil, which is here on the right and here on the left. It is important to remember this structure because sometimes the tonsil can be displaced through the foramen magnum, and this can be caused by a number of different mechanisms. If we remove the brainstem and look at the ventral surface of the cerebellum, you will notice two structures. The first one is the nodule, which is an extension of the inferior vermis. And here is the flocculus. Together, these portions of the cerebellum form the flocculonodular lobe, which is thought to be a functional lobe in its own right. I will also discuss this further later on in this video. The cerebellum is directly connected to the brainstem via bundles of white matter tracts, known as peduncles. With the brainstem removed, we can see the cerebellar peduncles, which are formed by these white matter bundles. The superior, middle, and inferior cerebellar peduncles connect the cerebellum to the midbrain, pons, and medulla, respectively. Now, if we change the model to a hemisected brainstem and cerebellum, we'll be able to see the relationships of the cerebellum. So ventrally, we can see structures that make up the brainstem, including the midbrain, which is approximately here, the pons, and the medulla. Here we have the cerebral aqueduct leading into the fourth ventricle. On this view, we can also see the general macroscopic arrangement of the cerebellum. The cerebellar grey matter extends around the cortex, like so, but it also extends deeper within the cerebellum, giving this leaf-like appearance, which is known as the cerebellar folia. The white matter extends through the deep grey matter as channels, or like branches of a tree, and for this reason is known as the arbor vitae, which translates as tree of life. The cerebellar nuclei are located approximately here. So on the screen now, I've added the left portion of the cerebellum and brainstem, along with the general arterial supply. The blood supply to the brain comes from two sources: the internal carotid arteries, which we can see here, and the vertebral arteries. These arteries pass into the cranial vault via the carotid canal and foramen magnum respectively. The internal carotid arteries form the anterior circulation, and its branches form the infamous cerebral arterial circle, which is often referred to as the circle of Willis. The vertebral arteries form the posterior circulation. As the vertebral arteries pass through the foramen magnum, they join to form the basilar artery, which we can see here extending over the ventral surface of the brainstem, which then meets the cerebral arterial circle approximately here. The cerebellar arteries arise from the posterior circulation. The arteries that we are concerned with are the superior, anterior inferior, and posterior inferior cerebellar arteries, and if I rotate the model, we can see them here. So, the superior cerebellar artery arises here, approximately at the terminus of the basilar artery. The anterior inferior cerebellar artery arises from the basilar artery, approximately over the pons. And finally, the posterior inferior cerebellar artery arises from the vertebral arteries, as we can see. So let's have a look at the territories that these arteries supply. The superior cerebellar arteries pass posteriorly and supply the superior portion of the anterior lobe, as we can see. The anterior inferior cerebellar arteries supply the flocculus, the superior part of the posterior lobe, and potentially parts of the anterior lobe, as we can see. Finally, the posterior inferior cerebellar artery supplies the inferior portion of the vermis and the inferior portion of the posterior lobe. So in this final portion of the video, I'm going to talk about the functions of the cerebellum. The cerebellum is concerned with motor control, works at an unconscious level, and for the most part will only may include coordination, motor learning and memories, as well as the initiation of movement. Cerebellar lesion. The spinal cerebellum may include the vermis, paravermal regions, or it may extend over the whole anterior lobe. It is thought to be concerned with posture, monitoring and correcting motor activity, and possibly coordination. Finally, the cerebrocerebellum is associated with the cerebellar hemispheres. These areas are associated with higher level functions that may include coordination, motor learning and memories, as well as the initiation of movement. Cerebellar lesions are associated with the signs and symptoms included within the text box here. The best way to remember these signs and symptoms is by remembering the mnemonic Danish. So that's me. We'd love to hear your feedback on what you thought. For the most part will only influence motor activity on the ipsilateral. Let's have a look at and so this can be confusing. Therefore, I've tried to collate as much information. The spinal cerebellum may include the vermis, level functions that may include coordination, motor learning and memories, as well as